square root undoes a square, or at least they're learning it. That's what they're trying to learn. Inverse operations of harder things beyond addition, subtraction, multiplication, and division. So they've learned, hey, I can get rid of that by squaring. So what's the problem? What are they going to do? They're going to get an answer, but what's the problem? The answer looks like it works, but is that even possible to begin with? No. So they had the square root of x is equal to -2. They solved and they all got x is equal to 4 and they were feeling real good about themselves until I'm like, check. And I'm like, that's a stupid word in math that we never do because it takes time. But the problem is when I actually had them do it and they plugged in 4, it became a +2 and not a -2, and all of a sudden their entire mathematical foundation is shaking. So it's like, wait, no, math, you do the legal stuff, you get the right answer, you're done. That's kind of what's hard but also annoying about it. Do steps 1, 2, and 3 and you have the right answer, you're done. But what's the trouble as soon as you get to more complicated functions? Are they doing legal steps? The answer is yes, but they're not familiar enough with the radical to know that this was never possible. And so this whole idea of extraneous comes in when it's like, hey, wait a minute, some of these more complicated functions like square root of x or ln of x or sine inverse of x that only works for certain values. You could do legal math to do the inverse of the operation and get answers that you would think would be right unless you knew at the beginning what was legal or not to actually happen. And that's frustrating, especially for an Algebra 1 kid to think about, let alone you guys in Precalc with LNs being like, what? You kidding me? Like it looks like it works, but it doesn't? But I guess there's some ties into life too about what? Going through all the right steps theoretically should lead you to the right answer or lead you to this certain place, but it doesn't always. When things get more complicated, even going through all the right motions or doing all the right steps still might lead you to a different conclusion or result, which is frustrating, but it's reality. That's why we do our best and give the rest to the Lord. Okay, but coming back. So, reduced row echelon form. We have to be careful to legally go through each and every step. And what I've written at the very end of this is, if possible. Why if possible? Because sometimes it's impossible. Remember section 7.3? Row echelon form, the stair-step solving systems of 3 equations. What's something weird that could happen? You're looking for a single intersection point, a single XYZ. What's something that could have gone wrong when we were trying to do our stair-step, kind of like this? What's something that could have gone badly and we had to kind of make weird answers? All right, open your notes. You have table of contents. Go to section 7.3. Go to section 7.3 and go find me the weird stuff that happened. You don't need me for this. 7.3. What was some weird things that might have happened when you were solving systems of equations? I'll give you a hint. It starts with the word let. Sometimes we had to let z equal a. Thanks, Matthew. When did we have to let z equal a? What if they only gave us 2 equations and we needed 3? What? Did you find that example yet? What if they gave us 2 equations and we needed 3? What if you ended up with 0 equals 0? They're still out there. Hey guys, who's not with the happy birthday during class? Okay, so if possible, what if you ended up with 1, 0, 0, 0, 1, 0, 0, 0, 0? We might still have to let z equal a. So if you guys want to make a note to yourselves, you can even reference section 7.3. But sometimes we might still have to let z equal a. Just be aware it's a thing. But for right now, let's not worry about the weird stuff or what could happen. Let's focus on one where it does work. So write down the system of equations. X minus 4y plus 3z equals 5. I'll zoom in a second. The next equation, negative x plus 3y minus z equals negative 3. 2x minus 4c equals 6. This is definitely harder than the one that we saw yesterday. We have 3 unknowns and we have 3 equations. The nice thing is we have as many equations as we have unknowns. We're going to be playing with numbers. Remember, we're looking for an alternate way of solving systems of equations, realizing that 7.3, even though it works, was tedious with 3 by 3s, let alone, oh my goodness, what if we had 4 by 4s or 5 by 5s or 10 by 10s? That would be ridiculously hard. We would have to do so many different rewritings of equations, it would be so tedious. It would work. I'm pretty confident some of you guys could do it. It would just be pretty annoying. Now, if some of you guys want to, well, this is a dilemma. I'm going to have to explain solving it this way. So if I were to set some of you guys off and be like, hey, if you want to do this the row echelon way, go for it. I could set you off in that direction. The problem is then you wouldn't be listening to how to actually solve. But I do think I could probably beat at least half of you, if not all of you, by going, you guys going the 7-3 way and me going the matrix way. Well, let me not prove a point quite yet. I want you guys to all see how to do this first. Maybe we'll prove a point tomorrow. What have you seen me do so far? What's been done to put this system of equations into this matrix? Yeah, technically, if you remember matrix multiplication, which we're reviewing in section 8.2, it's coming. But technically, because they were all x's, all y's, all z's, I factored out the x, y, z's, and I took them off to the side. And I took all the coefficients and all of the constants, and we did what was called, we augmented them together. Okay. If you guys remember from yesterday, if you have your notes, just read them. How do we do row echelon form? We work by what? Rows or columns? Work by columns. What do we get first? Multiply by the reciprocal in order to get the 1. The 1, it's not always the first, but the 1 in the proper spot for that column. Get the 1, and then after we get the 1, what do we get? What's step 2? Get the 0. Get the 1, then we get the 0s. We're going to go for a reduced row echelon form because if you guys see what we did or what we wrote down on the page before, we could stop here and still have to back substitute, or we could just keep going a little bit farther and have the answer without having to rewrite this with x's and y's and z's. In my mind, it sounds better just to stick with the numbers. So, here we go. In the first column, remember, we're trying to get to an identity matrix. In the first column, we want the 1 in this spot, which we already have. But now we need to get the 0. So I'm skipping the multiply by the reciprocal part because I already have my 1. And I'm skipping ahead to multiplying whatever row has the 1, R1, multiplying him by the opposite of each of these guys in order to add and eliminate these numbers to make them zeros. So first of all, I can say, hey, that 1, that -4, that 3, that 5, they're good. I'm keeping them. For that first column, he's already done. He has his 1. But then I'm going to go ahead and do the opposite of -1, which is +1, row 1 plus row 2, putting it into row 2, into the new row 2. And then I'm going to go ahead and take -2r1 plus r3, taking it into the new, or making it the new row 3. Why am I doing all of this? To get my zeros. Oh, there he is. To get my zeros. So, mental mathers. You guys can probably do it like I'm about to do it, as far as just kind of working through term by term, doing the formula over and over and over again. Non-mental mathers, take this off to the side and do your work and say, okay, who is 1r1? Who is r2? Let's go ahead and add. Who is -2r1? Who is r3? And add. Kimia, once again, remember, not changing the values of the rows, just going off to the side and using this equation to get to the new one, right? So then when I'm going ahead and plugging in, -1 plus 1, mental mathers, we're going to go for it. You get 0. 3 minus 4, -1. -1 plus 3 is 2. -3 plus 5 is 2. That one's nice and easy because I'm just adding what I've seen. Non-mental mathers, if you had written out row 1 and row 2 and added them, you would have gotten the same result of that 0, that's -1, that's 2, that's 2. But the next one is where it gets harder. Most of us could have added those two just looking at it. This next one, though, said you have to double, not even double. You have to multiply by a -2 and add. So non-mental mathers, I would definitely write that off to the side, at least for right now, as you're trying to get the hang of it, and then maybe you'll be able to speed up. Mental mathers, here we go. We have negative 2 times 1 is negative 2 plus 2 is 0. We have negative 2 times negative 4 is 8 plus 0 is 8. We have negative 6 minus 4 is negative 10. And we have negative 10 plus 6 is negative 4. Now you almost have enough just to go and finish. And if you do understand the process, get ahead of me. That way if I make a mistake, you won't make the same mistake with me. You can double check my work. But we haven't technically done the full process because I didn't have to work for this one. It was already there. I had to work for my zeros, but I didn't have to work for the one. So Nikki, I'm coming to you in just 1 second. I just want to show what you would do if there wasn't a regular one right now, which there's not in the second column as we go to make our one in its appropriate place before making the zeros. So multiplying by the reciprocal means, what is this number? Negative 1? Awesome. Let's go ahead and multiply by the reciprocal, which is 1 over negative 1. I know it's negative 1, but still the idea, you can always multiply by the reciprocal, it will reduce. If I multiply this guy by his reciprocal, I will always get 1. 2 over negative 1, 2 over negative 1, and I rewrite the rest. And now all of a sudden I have my 1 in its proper place in column 2. And I'm going to basically do the exact same thing I just did, except this time using row 2 as my reference to multiply by the opposite and add. Nikki, what's that?
Why did you write 1 on 1?
Well, why did I write negative 2 on it? Did that one make sense?
Yeah, but...
So I did the process to both. If I was a computer, I wouldn't really know what's in there and I wouldn't really care. I would just be filling in a formula. So if it's the opposite of times, the opposite of 2 is negative 2 times, the opposite of negative 1 is positive 1 times. So I just did the process. Which I'm about to repeat right now, because now that I have this, I'm going to use my R2 to add to, I'm going to use row 2 where the 1 is, to add to row 1 and to add to row 3. Except if I were just to add, I'm not going to get the zeros that I need. So I need this one to be multiplied by his opposite, 4, and his opposite, negative 8. The same way I multiplied by negative 1's opposite, positive 1, and 2's opposite, negative 2. That's something I could tell a computer to do. Take the entry, make it opposite, negative whatever's in there, and multiply. And then add. I'm going to zoom on in because my people that are off to the side, you can take this little formula, you can write it out. You can take this little formula, you can write it out. Multiplying every single piece by 4 and then rewriting, or multiplying every single piece by negative 8 and then rewriting, you can add. I'll show that in a second once I get this row to double check it. Does anyone know that has matched my exact same matrix with 1, 0, 0? So as I go ahead and do my mental math, the nice thing is if you do this in the proper order, working by columns, 1 then 0, the next column 1 then 0s, you're never going to mess up what you've already done in an earlier column, as long as you go this method. Because 4 times 0 plus 1 is still 1. I don't mess up the 1. 4 times 1 is 4 minus 4 is 0. And then I have negative 8 plus 3, and I have negative 8 plus 5. Moving down here, negative 8 times 0 plus 0, still have my 0. I'm preserving it. That's the whole point. Negative 8 plus 8, 16 minus 10, and 16 minus 4. Now, for those of you that might be doing that mental math style or even the other way, you're double checking me, making sure I'm right, but off to the side, let me model really quickly what I mean by if you're not a mental mather, you can be doing this another way. This can be on one side of your homework paper, on the other side, like in your homework spiral. This can be like in the actual problem, and this can be that page before on the back. You could actually take that earlier row 2 and multiply everything by 4. 0 times 4, 1 times 4, negative 2 times 4, negative 2 times 4. Rewrite R1. 1, negative 4, 3, 5. And then just add down. That's 1, that's 0, that's negative 5, and that's negative 3. Did I get that row right? Yeah. You don't have to do it all in your head. You could do little baby, basically eliminations off to the side. You could do little baby, basic eliminations off to the side. You could show the work. that way. Anybody match up? I mean, I matched up my first row. I think I'm good. Third row, good? Make mistakes. Give me a thumbs up if you're like, yeah. All right, I'm almost there. What column am I in now? Third column. Where do I need my 1? 833, right? Third row, third column, this spot right here. What's there currently? What does my system tell me to do to get rid of the 6 and make it a 1? So I'm doing multiply by the reciprocal. Multiply by the reciprocal. Anything else is going to mess up my zeros. I have to multiply by the reciprocal to not mess up the rest of the row. So 1, 6, R3 says 0 times 1, oh, still 0. 0 times, oh, still 0. That's the point. 6 times 1, 6. Ha, 12 times 1, 6. Hey, Z equals 2. No. But then you have to back substitute. That's annoying. So keep going. You have to back substitute. That's annoying. So keep going. How do you keep going? You just got to get your zeros. How do you get your zeros? Use your R3 now. You're going to multiply R3 by something to add to R2. You're going to multiply R3 by something to add to row 1. You're trying to do little baby eliminations. Opposite of negative 2 is positive 2. Opposite of negative 5 is positive 5. I have my 0, 0, 1, 2. That's done. Now it's time to do the rest. 2 times 0 plus 0. 2 times 0 plus 1. 2 times 1 minus 2. 2 times 2 minus 2. Hey, y equals 2 also. 5 times 0 plus 1, 5 times 0 plus 0, 5 times 1 minus 5, 5 times 2 is 10 minus 3 is 3. How can you guys double check that I'm right on your graphing calculator? Remember, we're not just trying to be able to do this by hand, but also by calculator. Can you guys go put the original matrix in your A spot, and then can you find under the matrix math menu the RREF feature? Go. Review from yesterday. Okay, where are the matrices? Okay, how do I make a matrix? Okay, what size is this? Put this matrix in. In A would be my advice. I mean, I guess you could do B or C. And then, matrix math menu. What's she talking about? Matrix math menu. Go find RREF. Huh? 3 by 4. Because I need to get all the information in there. You can try a 3 by 3, but it's going to be quite discouraging when you try to do RREF. Because it will say, here's your identity, it's possible, but it won't tell you any of the answers. Is it working? Did you find it? What did I mean by RREF? Pause for a bit, just because you're really going to want to know it's for the test. Ready? Okay. Matrix menu. This matrix. Super helpful for this. Second, x negative 1 button. Enter. Make me a 3 by 4. Did you guys get a 3 by 4? 3 down, 4 across. Put in these first values, the very first one. I got one person who got it on their calculator. Anybody else? That's the matrix. You want this to turn into this without any of that work if you're allowed to use your calculator. But once you put this matrix in, go to the matrix math menu. So go back to matrix, go over to math, go find the RREF or reduced row echelon form. When you hit enter, do you guys see that there's a parenthesis like it's asking for something? Did anybody find the RREF and you hit it? Wasn't it asking for something? What is it asking for? Well, guys, you could have made a million different matrices. Not literally. I don't know. What do you see? A, B, C, D, E, F? They need to know which matrix that you wanted to do RREF to. So, did you put it in A? Go back to your matrix, hit the name, hit name A, and then hit enter. what happens?
Error data type.
Uh-oh. Did you make a 3x4? Wait a minute, so if I knew how to use this on my last test, I actually could have solved every single system in my calculator and then known what the answer was before you. Wait, you could have found a solution by plugging in and checking. You did the same, you could have done the same cheating backwards trick. This is pretty snappy to solve any system in equations.
I got it.
Oh, you couldn't even show me.
You mean I could do it backwards? No, you
Might
can't.
actually come to the word color.
In the matrix. Yeah, you put in the beginning matrix into the
Anybody not got their calculator to work yet?
Oh.
Oh. Now go, because this is where we can have the things happen. Now go find the Oh, Dylan. Yes. Nathan. Hi, some people don't have calculators. Can you show them really quickly how you got it to work if you didn't yet? Does Kimia know? Does Kobe know? Can you show Kobe when you get it to work? Okay, so I'm not going to actually plug in the whole matrix. I see quite a few of you without calculators, and I'm not sure anyone around you has really loved on you and been like, hey, look, this is what I'm doing. So I'm just going to show you where to find the buttons, and that's about it. You guys, more than half of you checked and my answer was right? 722? So where did you guys go to find all this cool stuff? You're at the home screen, now what? Second, x to the negative 1, yeah? How do you make a matrix? Oops, wrong way. Edit. Make it whatever size you want. Nathan asked the question 3x3 or 3x4. You need all the information, so 3x4. In order to put this in, you need it to be all x's, all y's, all z's, all numbers. But if it ever wasn't in that form, you should put it in that form yourself before ever going here. This is an organized rectangular array. So I have x's, y's, z's. Now this is not this one. I'm not going to take time to do it. But you make the matrix. You go back to the home screen. Now what? Second? X to the negative 1. Math. I'm going to go just like I kind of do with like second trace to go to the calc menu. I'm doing matrix math menu. I would go up. Oh, that's annoying. if that really saved much time. REF would get you that back substitution form, but that's annoying. Go all the way if possible, please. And then second, matrix, I need to get, oops, that's not the right one. I didn't hit the second. Second, matrix, get the A. There we go. Second, matrix, get the A. Enter. Now, mine was different. It was a whole different system. It wasn't yours. But that's how you could have and should have and would have gotten 722. Now, careful, guys. Where could something have gone wrong? Let's assume you remember all of this. You know how to make a matrix. You know how to do RREF. How could something still go wrong even though you're using your calculator? Yeah, totally. Or like you went to hit the negative and it didn't really register and you didn't realize it didn't register, right? Or you went to hit enter and it didn't really move over, so you put two numbers in one column. Is data entry pretty important on things like maybe taxes? Accounts payable, business managers. Anyway, data entry is important. It's a thing. Lots of jobs out there in it, but you have to be very precise as you do it. Anyway, all I have to say is 722. If you guys correctly put in the matrix and you found the RREF, all of a sudden you're like, wait, I can solve any system, any size, just with my calculator. But we're trying to help you also understand how the program came about and how matrices work. So all of that to say, back in section 7.3, could you put all of those into that matrix and done RREF to solve? Yes. However, what's this little note that's still at the bottom? If possible, which means something could, even though this is really cool, something could go wrong. So why don't you guys try to put this one in your calculator now that you've learned how to do it? Using your calculator. This one says, like, literally, use your calculator. You don't even need to write anything out. Not really, unless you want to write it down. But can you guys just tell me what you're typing in, even though I'm not making you write? What are you typing in? 2? Negative 1. Okay, that one was basic, though. How about the next one? You have to keep it organized. 0x, good. 2y, negative 3z, 14. How about the last one? You have to have it organized. If you put anything in the wrong column, you are making what was an x now a y, what was a z now an x. You have to make sure they're all nice and organized. Unless they're really focused. But this one totally says, put it in and use your calculator. So you're like, nice, I just learned how. I want you guys to read for me exactly what appears. Nathan, you got it? The identity, the whole thing? Have all those nasty decimals and like a multiple choice answer? Maybe, maybe not. What if they had all their answers in nice little fractions and your calculator just gave it to you in decimals? Do you guys know how to take decimals and make them into fractions? Where's that? Let's go to frac, please. Where's that? Isn't there a cool math menu? Isn't there an over menu? Is it math and then over? I think that's it, right? Oh, there is the shortcut too, yeah. There's either math and then over and then frac. Someone double check that that's the proper order. Or there's the alpha. Nathan, what was it? The alpha window? Oh, what's the name? I was thinking it was window. Sorry, I couldn't get my head. And then isn't it the last one? What's the last one? Is it number? 4. Remember? That is our second x to the negative 1. Get into that matrix and then go over to the math menu and then go to, I think it's B. So second to x to the negative 1, go over, go down to b, or just hit the letter b, but that's kind of awkward. There's the RREF, but Aiden, make sure you do it from the home screen. All right, what happens when we go to frac? Are there nice fractions that appear?
106 over 17. 254 over 17. And 9.
Question, how fun do you think that would have been by hand? Not fun at all. Why? Now imagine, how fun would that have been to do section 7.3, the stair-step method, and do tons of back substitution? Yeah, maybe. Would it have been possible by hand? Well, let's just say Honors and I had a little bit of fun with it until they gave up after about 3 matrices. And so then they weren't double-checking my work, so that was a bummer, because I actually got to the very, 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 very end. Ooh, if I can find it. Can I find it? Where is he? There he is. I got to the very, very, very end, and then I made a silly mistake with my multiplication. I got way down here, and then I made a silly mistake, and then I got off. But that's okay. They finally had to catch up, because they all gave up right around here when it got to the 20. Actually, no. Emily kept going, Sophia kept going here. But anyway, they finally had to catch up with me, and it turned out all my math was great until these final additions and subtractions at the very, very end. But yeah, it is a little annoying to do it by hand, but it's still possible. I would have gone straight to the fractions, boop, 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 and then I guess they had to match it with theirs. They had the decimals, they had to think through about how to get the fractions. But that is cool for you guys to know. If there are nasty decimals, you can make them fractions as long as they translate into fractions, I should say. But was it possible? Yeah. And what did I do? Well, I got my 1, finished off the first column. Second column, got my 1 multiplied by the reciprocal, finished off that column. Got my 1, finished off that column. As long as I was able to legally keep track of all my fractions, there it is, 196, 254, and 90. Oh, but do you guys notice their directions were differently? I just told them to solve. What did I tell you guys to do when we did it? Using your calculator. Yep. So, let me give you a couple more with your calculator. Let's see if you can problem solve how to do these, because something has definitely changed. Last time it was just like there were some zeros. This time it's like there are whole missing rows or columns. What do you guys think you can do? You realize your calculator is nice. You realize it saves you time, but how would you use it on these ones? How would you use it on these? Has anybody tried doing it 3 by 3? How'd that work for you? It didn't. It gave you an identity, and you're like, RREF doesn't work with a square matrix. RREF needs square, variable, coefficients, and then solutions. So how can you change this 3 by 2 to be a 3 by 3 to add this on at the end? Try that. You're missing your Z.
Well, it's not like that.
Well, that doesn't tell me anything, does it? Because 1x equals 1y equals. Remember last time? 1 equals 7, 2 equals 7. So in order for RR, you have to tell me something. I'm not saying it works perfectly. I'm just saying it'll work better. Nathan, what happens when you do that? Oh, okay, hold on. So it's like this. So it's not the true identity because that's not a 1, right? Okay. Whew. I was like, wait a minute, that's identity. There's some big trouble. And then what's over here? Okay. Can anyone interpret what the calculator? Now, it has gone as far as it can. If I did my row echelon form, if I multiplied everybody by a negative to get a 1, if I got my zeros, if I went to the next one, got my 1, got my zeros, if I went to the next one, I would have tried to get my 1 and it would have been impossible. There was no number there to multiply by the reciprocal. It would have been a 0. I would have had some issues. Whether you did it in your calculator or whether you did it by hand, you would end up in the same place. But here's what I need you to realize. What is this telling you? Is it no solution, or what's the other thing that can happen? There are two different things. Either infinitely many, like z equal a, or no solution. How do you know which one this is? Why? A second ago, didn't the top row tell you that 1x was equal to whatever was here, and we had 1x was 7, right? This would be 1x is 0. Okay, fine, whatever. What would this one tell you? 1y is, okay, fine. I mean, that's weird, but okay, whatever. What does this tell you? Nothing is all of a sudden 1. Impossible. If you ever get a false statement or a false matrix, do you see it? If you ever get a false statement out of a matrix, no solution. Which means all three of these 3 lines cannot all intersect in one unique point. These 3 lines do not all intersect at the same point. So there's no solution. So even doing the RREF, and technically, guys, this is RREF form, reduced row echelon form, because the first coefficient you come to in any row is a 1. The first coefficient you come to in any row is a 1. And then everybody else in that column is a 0. Now this one will technically come to a 1. And if it was all zeros, well, I wouldn't have any coefficients, so it would still work. It is in reduced row echelon form, but I need to be able to interpret the form and be like, oh, just kidding, that's impossible. But how do we make this one into a nice, like, matrix that my RREF can understand? What did you guys do in this one? Yeah, put zeros in the bottom. Has anybody gotten that and what ended up resulting? What did you get, Nathan? Do I have a false statement? No, because isn't this just telling me 0 is 0? True. Wait, whenever we have true, what did we do in section 7.3 when we had true? It starts with the word let. We're going to do the same thing here. This is not no solution. This does not mean it doesn't intersect at all. This means it doesn't just intersect in one point, it intersects in like a line or a plane. And so how do I do this? Well, guys, sometimes there's no other way besides back substitution. So we can go ahead, still in reduced or echelon form, which is weird. I just want you to be ready for the weird ones. The first thing you come to is a 1, and then zeros in the rest of the column. The first thing you come to is a 1, zeros in the rest of the column. The first thing you come to is, okay, fine, we're done. There is no coefficient we come to other than 1. It matches reduced or echelon form, and those don't have to be zeros because I never got the 1. So all I have to do is say, okay, cool. X minus 8z is equal to 4. If I plug in a, x is equal to 4 plus 8a. And then I have my y plus 12z is equal to 1. And so, what? Y is equal to 1 minus 12a because we're plugging in z is a. And then solving. And so we end up with one of those weird solutions. Now remember, the book can sometimes make these look different. differently than we expect because they want like fractions to be pretty or something, but I don't see any fractions. They shouldn't do anything differently. And if it is different than the back, just bring it to me tomorrow and let me see it. And we'll see whether or not yours is accurate as well. And if worse comes to worse, you could always just kind of plug in some numbers and see if it's getting out the exact same values. What if A is 1? What if A is 2? Are you guys getting out the same numbers? Oh. What? When's this homework supposed to be due? Monday. So what does that mean that I'm a little worried about, even though I'm saying you technically could go tackle homework, what do you think I'm not still totally sure that you have mastered? Maybe word problems. There might be some weird things that happen at the end of section 8.1. What else? What did I show you today? How to use your... And as soon as I showed you that, what did some of you totally tune out and ignore and hope that we never have to do again? Maybe all the stuff in chapter 7, but maybe also the RREF by hand. So we're not going to spend all of tomorrow doing section 8.1. We're just going to spend like the first half-ish of it. And we're going to have a 4x4. We're going to have, wait, what's a 4x4 mean? How many variables are there? Yeah, like X, Y, Z, W, or like A, B, C, D. We're going to have 4 unknowns, 4 equations. And you're going to have to solve it. For what is X, what is Y, what is Z, what is W, and you have an option. You can either do 7.3 stair-step method, aka take the first 2, eliminate X's, take the second 2, eliminate X's, take the third 2, eliminate X's, then go eliminate Y's, then go eliminate Z's, then find a W, and then back substitute. Or you can do the matrix by hand with me. I want you guys to be pondering as you're doing homework tonight. Can you do it by hand? Now, hopefully you can use your calculator to double check whichever method you do at the end. But tomorrow, all calculators start underneath our desks. And you, in the back of your homework spiral, have to choose how are you going to solve that 4x4 by hand. Ponder tonight, do as much homework as you can to practice for that. I mean, we're not practicing 7.3, but if you guys want, you could be like, nope, I'm going to be stubborn and do it this way and pretend like I did it with matrices. Okay. But you guys want to be pondering, can I do it by hand? And then tomorrow, thank goodness, it's like in after class, you get to go into like, hey, how do you add these things? How do you subtract these things? Let's do some basic math with matrices. Bye, guys.